All right, looks like we're ready to go. I'm David Shepard. I'm going to present proof patterns for speed and security in AWS. This is in my About Me. I'm a old-time CISSP, AWS, FinOps, IDLE, PMP certified, all those things. Day job, I work at Freddie Mac, and I'm a senior tech lead in cloud security engineering. Some stuff about my background. I've been doing this for 30 plus years. Started as a Fed, moved into consulting for about 18 years, moved to financial services about 8 years ago. So Freddie Mac, if you don't know Freddie Mac is our mission is to make home possible. We don't build houses, we don't buy houses, we don't sell houses. We basically buy the mortgages from the banks that give you money, and then we turn them into securities. And the intent of that is to ensure that there's liquidity in the mortgage market. So the banks that have the money and give you the money sell us. Basically, they sell us their loans, and we give them back the money, and then they can sell more homes, or they can have more money in the market. And Freddie and Fannie Mae are two companies that do that. We're a bit odd as we're how do we say it? We are a government-sponsored entity currently. About a quarter of the homes financed in the U.S. are financed through Freddie Mac. 7,000 employees. We were funded by Congress, or founded by Congress in 1970. And again, our mission is stability in the housing market. And a lot of that is making sure there's money for folks to buy homes, and there's money for loans. We're going to start with the story, and this story is about Studebaker, the company. Studebaker started in 1852 in South Bend, Indiana, about 2.5 hours north of here. And Studebaker started building wagons and carriages back in 1852, and the kind that horses draw. As the automobiles came out, they were the only company that moved from making wagons to actually building automobiles and building cars. In 1902, they released the first electric car. Electric didn't last at that point because the battery technology wasn't there and the gasoline engine was coming. But they did really well. In 1951, Studebaker was the 8th biggest U.S. automaker. They had about 5% of the market, and they were it was boom time. And then the big three kind of made things uncomfortable for Studebaker. Some stuff happened, and basically in '63 they closed the factories in South Bend, Indiana. There was a lot of layoffs. The entire town went into decline, and there was just decades and decades of decline in South Bend. So bad things happen when you lose your main industry, and South Bend was one of the first towns to really feel the impact of the Rust Belt and the deindustrialization. And so there were huge problems in South Bend, and over time, houses became uninhabited. They fell into disrepair. And at one point, in that purple map, this map, I think you can see this. This map, all the purple there are empty lots where houses, they're so dilapidated, nobody can live in them, or the houses are already down. And it got bad enough that Newsweek magazine in 2011 put out a list of America's dying cities, and South Bend was on that list. And they were in crisis mode, and it had been bad for a very long time. So the challenge for South Bend was they had a whole bunch of abandoned and derelict houses. And you can read the list, but things were not going well. And so their solution was they built a thing called Build South Bend. Basically, Build South Bend was the concept of let's not just encourage people to build houses, let's make it easy for folks to build houses. So they built these pre-approved plans, and they basically came up with a collection of designs of houses that they felt would work in South Bend, that would support the community and support the growth of the community. And they essentially gave out plans, or any builder, any person could go get plans for a house, and they were pre-approved with all the ways that they want you to build your house to meet the requirements of the city and the state. And so people didn't have to guess at it. It became more of a here's your design, pick the kind of house you want to build. Oh, you'd like a 2-story duplex? Sure, we can do that. Side-by-side duplex, here's the plan for that. So they just tried to make that easier. And you can see in the Build South Bend plans, they actually did this really well. They were smart enough to even look at these little carriage houses, which is a kind of an augment. And this was in 2011, I think, when they did this. A carriage house was an augment to like you'd have a main house and then you'd have a carriage house behind it. And oftentimes that was a garage with a one bedroom apartment above it. And so they were thinking about how can we encourage both affordable housing and some potential income for the people who own the main house. So they were thinking about how can we support the community and build new homes and make this easy. And they did all kinds of homes, including 6-bedroom apartments. And at work, we were talking about this. And so these are those pre-approved plans for the houses. These are the pre-approved plans for an apartment building. We were talking about how this mirrored what we were thinking about with our own builds for how we want folks to build in AWS. And they built these infill plans. And in South Bend, in this plan, the white houses here are the houses that are existing in the neighborhood, and all of the other orange-ish colored houses are houses that are available that could be built on those lots. So this is an infill plan. So you have a neighborhood that's half full of houses, and they're trying to figure out how to make more. And so we looked at this, and we looked at how city blocks and the build for city blocks kind of mirrored what we were trying to do with cloud infrastructure. The whole idea of pre-approved house plans, having a catalog of house plans, having a building inspector, having a permitted construction process, and basically having standards for your neighborhoods and how they should be built. It's a lot similar to what we're trying to do with the cloud, which is have plans, and those plans could be CloudFormation templates or Terraform templates. Have a library of those, so a pattern library of here's CFT. If you're a CFT team, here's CFT to build a Lambda. Here's CFT to build a Lambda with an attached EC2 or an EC2 with an attached Lambda, and have those plans available, make them all policy as code. So essentially take all of our security requirements and build them into those plans so folks can accept and adopt our plans. And when they build using those plans, they build to the spec. Now they can tweak, just like the homes in South Bend, you can tweak and how in South Bend, they talk about this in the plans, you can tweak the way you want your eaves to look. You can tweak how your overhang for your porch looks. And there are things you can change, and there are some things you can't change. Like you have to hook up to city water, and you have to have a sewer connection, and you have to have power and that kind of stuff. So you have standards that you want folks to follow. You validate those standards. Same thing we do in cloud. And so let's talk about that a little bit. So if you have a house, the things you want is your own space. You want some solid construction. You want some room for your stuff, and you want to control who can come inside and who can't. You want to control what's allowed in and out, and you want to control what happened and when it happened. And in a house, you do that with it's your own space. You have your fence around your yard, your fence around your space. You have a house with walls. You have interior walls, and I think of those as like layers of VPCs. So yes, we have a house with a fence around it, and inside that fence we have the walls of the house, and inside the walls of the house we have kids' bedrooms and parents' bedrooms, and different things happen in different sections. So I like to think of it that way. Quality construction in the world of the house is, of course, a foundation. I'm going to go ahead and show the other one. The way we look at foundations is golden AI images, and we build golden AI images for our folks to use. And our intent is to have folks use an image, and as an image gets older, rehydrate and get a newer image. So we don't spend our time patching stuff. We spend our time rebuilding EC2 instances on AMIs that we know are already patched. So we pre-build with all of our requirements into those AMI images. Again, building a quality foundation. Storage, of course, is EBS EFS S3, so we have rules for that. All that's built into our plans. Who can come in? IAM permissions. What is allowed in and out? This is kind of a stretch. We're thinking about windows and locks, and we're looking at security groups, basically what ports are open and what ports are closed. Who do we allow to hit our stuff from the outside or adjacent? And this last one, the what happened where is make sure we have logging turned on. We have CloudTrail. We have our CloudWatch logs. And as people stand up services, we ensure that those things all get turned on. So we look back at the plans, and so we think about these little carriage houses, and that's like a Lambda that's attached to an EC2 instance, or maybe a DynamoDB that's attached. And you might have like an EC2, which is a little bit bigger house. It's bigger than a Lambda. You might have an Elasticache tool, and you might have an RDS database, which sometimes is a pretty big house. And then we have these things that are the 6-bedroom or 6 6 apartment complexes, and we looked at those as like being ECS container, ECS or EKS, where we take containers and we might have 6 pods or 6 nodes that run inside of ECS, and we started thinking about those in that way. So we looked at the Build South Bend infill plan, and we came up with this pre-approved, secure, ready to build AWS infrastructure. And the idea was similar to that. We're going to give you the plans for, here's a EC2 instance with an attached S3. And here is, another EC2 instance by itself. Here's an EKS cluster. We're going to give folks the plans so they don't have to figure it all out on their own. And the intent there is to give folks meaning our dev teams, a place to start so they're not going out and having to learn, okay, we have, of course, like every good organization, you have a list of your requirements for security stuff. Those aren't always at a level where you could just say to a developer, go look at the list of what we refer to as non-functional requirements, which is really a list of, hey, it needs to be encrypted, it needs to be, these are your password requirements, these are your baseline VPC requirements and all that stuff. Those have to be really tight. So the intent here is to give them those pre-built into the plan, and then to also recognize that as our developers get better at this, that they can inner source, they can provide updates to those, and they can make those tweaks to their porches and make those tweaks to their EC2 instances that make that work for them, and that becomes another separate kind of house they can build, another kind of instance they can build. Or for brand new services, they can help us build those things. So the intent is to engage the community. Again, so the pre-improved pattern library is, these are the things that you want to have in your library, how you have secure VPCs, your IAM roles, how do you do S3 buckets, how do you do Lambda functions, RDS instances, and the big one for us is EKS services because we rely heavily on that. And basically, how does this work? So a developer, a house developer or a IT developer picks a plan and starts working from that plan. They do some parameterization, so they decide what kind of ports should go on their house, or they decide how they really want to use this EC2, and they make maybe some minor tweaks, but they don't change the underlying, or they can't change the underlying security code requirements that are in there. Of course, just like you would have someone inspect a home as it's being built and checked, and we have inspectors that show up in a house that check stuff, you do pipeline validation. So as they're going through the pipeline, we check to make sure, yes, we gave them a plan that said that they have, CloudWatch turned on for all these resources they built. Sorry, not CloudTrail, CloudWatch logs being created for each of these resources. We validate that that's still being done. So we give them the plans, but we still validate, just like you would check the house as it's being built. We allow them to auto-deploy then. The deployment either goes through or doesn't go through based on if they meet the requirements or not. And then we do continuous compliance on the back end. Because just because you build a house and you build it perfectly doesn't mean that in 2 years it's still perfect. So just like your car, and you would take your car to get inspected, we do continuous evaluation of resources within our living environment, recognizing that things change and things, people make tweaks occasionally, and sometimes they're not great. So you want to know that immediately. So the payoff, the compliance by default, of course, you want folks to build stuff out of the box compliant. It increases the developer velocity. So the idea is that we just make it easier for them to have to know all the nitpicky stuff that we want set in the environments. We have consistent standards that are enforced for everyone who's building, and there's less toil on the teams to have to go and figure this out themselves. And the idea here is that you don't have to start from scratch, and that our developers don't have to start from scratch. We're going to give them a library of how we want this to work and how this should build. And from that, they can more quickly learn both how AWS works and how we want them to use AWS and make it work, and stay within the requirements. Freddie is obviously risk averse, so we want to make sure that people have the right stuff built when they build. These are my key takeaways from this, and this is a thing I've been saying to my team a lot, is we need to make the secure way the easy way. Regardless of what you do, developers and DevOps engineers are going to find the way that works for them. I want to make that first choice the most secure way possible. We want to build the patterns and encourage their understanding, increase speed, and allow them to intersource and add and improve those patterns with us. We want to continue to evaluate the resources when we build them, while they're running, and we also want to validate as things get torn down. The scariest thing to me is those resources that don't get torn down or don't get effectively retired. Oh, that S3 bucket that we had, that team is gone, but their S3 bucket has lived on and no one knows it's still there. I mean, kind of see it in the inventory, but nobody's really taking care of it. Those things scare me and keep me up at night. And the last part of this is, if you're going to build the patterns, you're responsible for maintaining and adding more of those patterns as you adopt more services and as your application teams move forward to new technologies. You have to continue to make that work. And I think I'm probably a little early. I don't know the time. Any questions on the concepts that we're pushing or the ideas here? Yeah.
In your pipeline validation stuff, you mentioned a tool called Checkoff. I am not familiar with that. What does that tool do for you guys?
Checkoff is an open source tool. It's one of the tools we run. We run a bunch of stuff in pipeline. Checkoff, I think, checks, and this is not my area of expertise, I think Checkoff checks the underlying code that's being deployed, but I don't know that off the top of my head. I know we run it. We also run custodian on things in our pipeline, so we look at things as they're being built. Right as they're being built, we're checking them to see if they meet those requirements, so we use a tool called Cloud Custodian to do that. We also use Cloud Custodian on an ongoing basis to check those things. And a number of other open source and other tools that we use to check stuff. Thanks so much. Appreciate it.